Dr. Gololo. I'm a senior lecturer in the Department of Electrical and Electronics Engineering.
And I'm Professor Mary Longe. I'm the Deputy Head of the Department of Electrical and Electric Engineering Science, University of Johannesburg. Okay, so today's Project Day event is very important to us as a department and also as a faculty. As you can see that we have our students displaying their various projects which cut across all the specialties that are involved in electrical engineering. A lot of them have gone through the process of thinking through a lot of things and be able to provide solutions to the day-to-day problems that we are facing in various sectors, in the energy sector, the communication sector, the biomedical engineering sector, the control fields. So we have all of the streams of engineering being covered by the various projects that the students are doing here, and we are using this to be able to show to the world the capability of our students, that indeed they are ready for the industry, indeed they are ready to provide and to show the world the next generation of solution providers, which we are raising here in UJ, and we are very proud of our students.
My name is David Bester. I'm a fourth year engineering student at the University of Johannesburg, and my project this year is to build a trapping cage monitoring system for the Kruger National Park. So the Kruger National Park actually approached us, the University of Johannesburg, to try and develop a system that would help them essentially monitor their trapping cages. So the Kruger National Park utilizes trapping cages on the post over there to capture and relocate animals which have either been hurt or are causing problems. Unfortunately, the systems that I use here are not really known. I was one of the first two students in the university to design a PCB and have it made by March. We ended up going to Kruger National Park and managing to test the system, so that was quite nice. It's unique from, for example, some of the other projects within the university because it has a real end user, the Kruger National Park, and that substantiates it a lot because it's not just a prototype, it has to actually somewhat function or be at least somewhat usable so that they can actually use it and hopefully change lives. Yeah. So very simply, all it does is determine what happens to the system. If the system state has changed, it gets GPS data, transforms it into a form that we can interpret, sends that via the Sigfox chip, which is just this fancy communication they use within the Kruger National Park. And then on top of that, once it's completed all of that, it simply just goes back to bed to conserve power. Ideally, the system should be able to operate for at least a year and a half, if my calculations are correct. If they use the system once a week or maybe twice to 3 times a week, it should be able to last at least 2 years.
Hi guys, my name is Kwena Mujela and my final year project is called a Smart Temperature Sensor. So this project was inspired by an incident that happened in Wire Minerals in Isando, where there was a machine that blew up because people couldn't see the local alert that was happening due to temperature rising of the machine. So at the moment, I'm having an error because of the code, but I'm just going to explain how it works, right? So the main purpose of this smart temperature sensor is the local alerts. When I say local alert, I'm talking about your LEDs, the buzzer, the OLED. So every time when the temperature turns high, as normal, you know how a robot works, right? The green LED will switch on, the OLED will say that the temperature is on normal, and the buzzer will be on silent. And then when the temperature is going to a warning state, the yellow LED will turn on, and then the buzzer will beep. And then the buzzer will beep like after every 5 seconds. And when the temperature exceeds the threshold, the red LED turns on and the buzzer beeps continuously. So this smart temperature sensor, it works with a GMS and a dashboard. So here on the dashboard, it shows the data of the temperature that it's sensing. So this is the live dashboard. So every time when it's updating, it also updates on the dashboard. And let's say that the temperature is getting very, very high, right? So the buzzer will beep, beep, beep. And then after that, if nobody comes to check it out, me as a person who is not in the plant, I can manually switch it off using the manual power out on my dashboard. So this manual panel out is used. You can switch it on and then it will gonna turn the whole system of the temperature off. What I can take from this project is how my coding was like more complete because I was using only one microcontroller. So everything was just added onto that microcontroller. So it was difficult for me to like try to power up some components. So, but I did enjoy my project. It made me to like learn more about the IoT.
Hi everyone, my name is Rarisa Morakile and I'm doing my 4th year here at UJ studying electrical and electronic engineering. My project basically saves life. It monitors your heart and sends alert to people. My project has 4 categories: your normal, your moderate, your severe, and your no pulse. Usually back then we used to have normal and abnormal, so I have added more categories. So basically my project is about monitoring the BPM of a person, and I have 2 apps for that. So one app is used to monitor the heartbeats per minute of a person, and then the other app is used for the guardians. So basically the guardian app is used to send coordinates to the main app, which is this one. So and it also calculates which guardian is near to contact in case of emergency. So it will be beneficial to them because family members will be able to track them wherever they are, and they'll be able to come to the emergency whenever the app detects the severe or the low pulse. So yeah, I've trained the data I'm using. I've trained it through PyCharm. This interface, as you can see here. So it uploads every other 10 seconds, as you can see here, it uploading. It comes to this ThinkSpeak where it sends the data from the PyCharm here, and it uploads every 15 seconds. We also have the Guardian Locate app. So this is where the coordinates of the Guardian Locate app come. Yeah. So then they go to the app, the different apps that I've shown.
I go by the name Tolo Mashia. I'm a final year engineering student at the University of Johannesburg. The love for stands, shows, and cars, that's what drove me into deciding this project, because I wanted something that I could do and have fun while doing. I would describe my project as high voltage and unpredictable. As you can see, people do not even think this is a project. People are just passing around here until someone has to notify them, "Evan, did you notice that project?" So this is something unique, something that has never been done. This is more like a business idea. You can open your own business and start doing this for other people. I have multiple requests of people that want me to do this to their cars.
For you out there, our future electrical engineers who wants to study electrical engineering, you are welcome. I want to advise you to take your maths and physical science very serious, because you just cannot cope without these subjects. If you are there, you are a female student, you want to study electrical engineering, I encourage you, do not see it as an impossibility. You can see I'm a woman, I'm an electrical engineer, I'm an associate professor of electrical engineering, so you can also do it. My little girl there, you can do it. Believe in yourself, believe you can make it, you can make a change.
I would just have to say, just follow your heart and take whatever project you are given and give it your all, you will make it.
What I would say is that do what you love, do not follow the trend of what's happening. That's it.
I could say that group work. Don't do anything on your own. Don't try to be a smart person and not get help. Engineering is all about group work, teamwork. You can't do everything alone. That's what my advice would be.